Let us solve one more problem from IIT-JAM 2023. There's a question number 28, section A, and this is basically from optics, optics polarization. So in that question, it is given you have a plane polarized light is incident on. You have a plane polarized light that is incident on quartz crystal. Okay, with respect that angle of incident, that is 30° with respect to optic axis. Okay, and the thickness of this quartz plate is given, that is 20 micrometer. Okay, the wavelength of incident light, that is also mentioned, that is 590 nanometer. Okay, and the difference between refractive index of O ray and E ray, that is also mentioned. For this crystal, the refractive index of O ray is differed by E ray by a factor of 0.009. Okay, so the phase difference between this O ray and E ray after transmission will be, that is mentioned, that phase difference of wave after transmission, that is f into pi. So you have to calculate that value of f, also the state of polarization of transmission light you have to calculate. Okay, so a beautiful question actually, and this type of question also asked in JEST 2022 also. So how will solve this? So let us assume that electric field amplitude of incident ray, that is E naught. Electric field amplitude of E ray, that is E naught, and let us assume this is the optic axis. The angle between that electric field incident and optic axis, that is 30°. So I can represent the state of that profile of incident light, profile of incident light, incident ray. For E ray, I can represent that profile, that will be amplitude. So total amplitude is E naught, component along optic axis, that will be the amplitude of E ray. As you know that if the if plane polarized light is incident at an angle theta, it will be splitted into two components in double refracting crystal. So that ray or component along optic axis, that will be E ray, and perpendicular to optic axis, that will be O ray. So I can represent that incident profile of E ray, that will be amplitude, that will be E naught into cosine 30. So that will be E naught into root 3 by 2. So that will be root 3 by 2 E naught, and you will have sine of omega t. Similarly, I can represent that profile of O ray. That will be E naught sine 30. So that will be E naught by 2 sine of omega t. So initially there is no phase difference. Okay. Now there will be phase difference of transmission ray. Why? Because of path difference. Because we know that path difference is nothing but when it is traveling that thickness T, that is mentioned 20 micrometer, there will be path difference between E ray and O ray. So that I can represent like delta X, that will be nothing but difference in the refractive index NO into NE into T. So that will be 0.009 on into T is given, that is 20 micrometer. So I can represent like 20 into 10 to the power 6 minus 6 meter. 20 10 to 10 to the power minus 6 meter. Okay. So that corresponding phase difference delta I can represent. So delta will be nothing but 2 pi by lambda into delta x, that we know. So we have a 2 pi, lambda is given, that is 590 nanometer. It will be 590 into 10 to the power minus 9 meter, and you will have delta, that is 0.0091 into 10 to the power, sorry, into 20 into 10 to the power minus 6 into 20 into 10 to the power minus 6. So if you calculate this, you will basically get 0.62 into pi. So this will be the phase difference of E ray and O ray after transmission, and that value of f I can see, that is 0.62. That is also asked to calculate. Okay, and I can see the phase difference between O ray and E ray, that is not in integer multiple of pi. So obviously the state of polarization of emerging ray will not be linearly polarized. Also it will not be circularly polarized because the amplitude is not same. Amplitude is not same, and phase difference is not like pi by 2, 3 pi by 2, 5 pi by 2, and so on. But I can see it is satisfying the state of polarization of elliptical polarized light condition. So obviously that transmitted ray will be elliptical polarized, and the phase difference between E ray and O ray, that will be 0.62 pi. Okay, thank you.